Welcome to the Hans Charming Foam channel. Come experience the beauty of open source wind energy. Hans Charming Foam represents the best wind energy visualization. It's currently a set of comprehensive open source case file and airflow converter tools in the early stage. And then it will definitely become a light software and interface dedicated to wind energy, which is what I've been pursuing in my open source wind energy work. At the beginning, let's think of a question. Why open source wind energy is important at this stage? Let's take a look at my story. Hope you enjoy it. Let me first introduce what an airfoil is. An airfoil is a cross-section shape of an object whose motion through the gas is capable of generating lift. Currently, the mainstream airfoil are derived from the cross-section of an aircraft wing. So what feature do you need to look to determine the good or bad qualities of an airfoil? Of course, a good airfoil must maintain a good lift and minimal drag. Aerodynamic optimization process can minimize the drag and a certain lift in a specific scenario through the deformation of an airfoil. What is the biggest challenge in obtaining these parameters? The answer is that this is a complex fluid dynamics problem that cannot derive analytical solutions. As a surface that does not towards the inlet has unknown pressure distribution, it can only obtain through the experimental measurement or CFD simulations. So its developability of the airfoil is very weak, as any optimization process must exist in CFD series software. There are two types of airfoil optimization, namely steady state optimization and transient optimization. In the steady state optimization scenario, the airfoil is assumed to be stationary. But under transient conditions, the airfoil might be defined as a series of slight and rapid oscillation. Since the transient airfoil solutions have so many motion states, it has much more computation time than that in the steady states. However, more reliable and accurate results can be obtained from the transient optimization. Let's move on to the airfoil of the vertical axis wind turbine. Although the airfoil is also taken from the horizontal cross-section, the situation becomes completely different. Firstly, the motion process of the airfoil is not a uniform oscillation, but an irregular pitching or rotation. If you are familiar with the CFD simulation, you may have heard about the term of user-defined function. For example, it could be a piecewise function that switches from the slow forward rotation to the fast reverse rotation at some point in time. However, CFDs for which they are currently optimizers do not yet have the capability to user-defined functions. Secondly, when the airfoil rotates a certain angle, the airfoil will be in the high turbulence mode when the chord perpendicular to the air inlet or trailing edge towards the air inlet, which is also the root cause dynamic store problem. In this case, if the constraints of the airfoil chord length or thickness are not changed, it will have abnormal deformation. This means that none of the previous optimizer parameter settings can be applied here. So under such complex conditions, how can we optimize the airfoil? At present, it is needed to the G-mesh to build models and meshes, use OpenFOAM or SU2 to achieve the CFD simulation and shape optimization results, and finally use a PyroView for post-processing through the surface extraction of the airfoil. As auxiliary tools, Python or MATLAB can be used to scale the number of airfoil points, generate a large number of G-mesh inputs, or manually define surface motions. If you are interested in Hans Charming Foam, subscribe now.